Hello students, in this video we'll find a recursion formula for integrating positive integer powers of secant of x. Let's define in to be the integral of secant to the nth power of x dx. Now we know the first couple values of I. For example, we know that I1, which is the antiderivative of secant of x dx, is the natural log of secant x plus tangent x, plus c, of course. We'll just leave that without the c. And I2 is the integral of secant squared of x dx, which is just, of course, is just tangent of x plus c, probably plus c if you like. So I know I1 and I2. The question becomes is if I want to find I100 or I5000, can I relate I100 to either I1 or I2 by a recursion formula? So let's see if we can do that. So what we're going to do is we're going to write In in a more suggestive way. We're going to write it as secant to the n minus 2 of x times secant squared of x dx. And now I'm going to integrate this by parts. How will I do so? Well, I know what an antiderivative of this thing is over here, so that's going to be my dv. This thing over here is going to be my u. And so what happens when I do this? I'm going to get u times v. So I'm going to get u, which is secant to the n minus 2 of x times dv, the derivative of the antiderivative of secant squared is tangent, minus the integral of v, which is tangent, times the derivative of secant to the n minus 2 x dx. So In is equal to secant to the n minus 2 x times tangent x minus the derivative of this. I'm going to pull that n minus 2 out of the integral, n minus 2 antiderivative of tangent of x times what? Times, I have the power rule, so I'm going to have a secant to the n minus 3 times the derivative of secant, which is secant x times tangent x dx. Now, of course, we're in the situation here with the restriction we have is we're going to let n be bigger than or equal to 3 because I know how to handle 1 and 2. So I'm going to assume n is bigger than or equal to 3. So that makes sense over here. And so now this integral over here becomes, so we have secant n minus 2x times tangent x minus n minus 2 integral. I have secant to the n minus 2 of x times tangent squared. But tangent squared, so I have tangent squared is secant squared x minus 1 dx. Okay? So now we're in great shape because what this is this is In, of course. So In is this expression. It's secant to the n minus 2 of x times tangent of x minus n minus 2. And then what's this first integral over here going to be? This first integral over here is going to be secant to the n of x. That's just going to be In. Great. Then over here, I'm going to have what? I'm going to have secant to the n minus 2. That's going to be minus In minus 2 dx. Well, now that we're done. And so now I can solve this for In. I can take this negative n over 2 and throw it on the other side of the equation. So I'm going to add n minus 2 to both sides of the equation. So I have a 1, and then n minus 2, that's an n minus 1. So it's going to be an n minus 1 In is equal to secant to the n minus 2 x times tangent of x, and then plus n minus 2 In minus 2. And so now we can arrive at our recursion relationship, which states that In is going to be secant to the n minus 2 of x times tangent of x over what? Over n minus 1. And then what? And then plus n minus 2 over n minus 1 times what? Times In minus 2. So this is a recursion relationship. So if I wanted to find I3, for example, I3 would be secant of x, tangent of x over what? Over 2 times 1 over 2 times I1, which is the log of the secant of x plus tangent of x. If I want to find I5, I could use what I found for I3 to find I5. So using this recursion relationship over here, we can find the antiderivative of any power of secant as long as that power is a positive integer. Thank you very much.